So today we'll be learning about addition and subtraction of fractions. So let's see how we do it. So in the last video we learned that fractions are equal parts of whole, and I also gave you the example that my friend ate 3 out of 4 parts of the pizza and I ate the remaining 1 out of 4 parts of the pizza. So if I told you to add these fractions, how would you do that? So by common sense, you will say that okay, so after I did that, I finished the pizza, right? So I ate all the pizzas. So I ate all the parts of the pizza. So I can say that this is 4 upon 4. And you can also say that okay, 3 plus 1 is equal to 4. So 4 out of 4 parts are finished. So it's 4 upon 4. Yes, this is correct. But this can't be applied to all fractions, right? So let's see how we can add these sort of fractions. So when the denominator is the same, there's a theorem that says that then in this case n1 upon d, n1 being the numerator and d the denominator, plus n2 upon d, so the denominator should be the same. N1 and n2 can be different, they can be equal to, so this will be equal to n1 plus n2 upon d. So these are just variables for the denominators and the numerators. So this is the numerator and this is the denominator. So so this in this case is 3 upon 4 plus 1 upon 4, right? So this will be equal to 3 plus 1 upon 4, which is equal to 4 upon 4, and so we have the answer. So let's just solve another problem. 2 upon 7 plus 3 upon 7. So this will give us 2 plus 3 upon 7 according to the theorem, and this will be 5 upon 7. So this happens to be the easiest way you can add fractions with the same denominator. But let's say you're given a question. Which is 2 upon 3 plus 5 upon 7. How would you do this? So let's see how you can do this. So the denominators are not common over here, and it's really difficult to add fractions without the same denominator. So we can try and make the denominator common, which isn't the case over here. So let's see how we can do that. So let's see what is the LCM of the denominators of 3 and 7 in this case, which will be 3 into 7, because 3 and 7 are prime numbers, which will be equal to 21. So this is 21. So let's see how we can proceed now that we know that the LCM is 21. So we have to make the denominator common, and the denominator will be 21 in both the cases. Why? Because that's the LCM and it's the least common multiple of these. It can be 42, it can be 63, it can be anything, but it's 21, it will just make the addition easier, and we want that to be right. So let's see how we can make them common. So 2 upon 3, so 3 needs to be multiplied by something to make it 21, and so does 2, and it will be the same one. So we can multiply both of them by 7. 3 will be multiplied by 7 to give us 21, and 2 by 7 will be 14. So this gives us 14 upon 21, and then we have 5 upon 7 over here. Now 7 can be multiplied by 3. We just have to do the inverse, and we get into 3. This will give us 15 upon 21. When these two are added, 14 plus 15 upon 21, this gives us 29 upon 21, or we can also call it 8 upon 21, which is the mixed fraction for it. So we've got the answer. 29 upon 21 or 8 upon 21. So what we saw here is that when the denominators aren't common, we can simply make them common by taking out the LCM and just then accordingly multiplying the denominators to get the common denominator, and we can just add them. So let's see how we can subtract fractions. Subtracting fractions with the same denominator is just the same. You just do the same thing. So let's say you have 3 upon 4 and you have 2 upon 4. You have to subtract. So the same theorem, it says that when you have n1 upon d minus n2 upon d, this will be equal to n1 minus n2 whole upon d. So let's see how we can do this. So this will be equal to 3 upon 4 minus 2 upon 4, which is 3 minus 2 upon 4, which is 1 upon 4. Now let's move on. And let's see the same thing. Now the denominators won't be common. So let's say 5 upon 7 minus 2 upon 3. The same number, the same fractions, just a different operation. So let's see how we can do this. As we know the LCM is 21, we can simply again multiply this one by 3, the numerator and the denominator, and this by 7, both 14 upon 21, and then we can simply 15 upon 21 minus 14 upon 21 will be equal to 15 minus 14 upon 21, which will be equal to 1 upon 21, and this is our answer.